Hello everyone, this is Mr. of Help, and today you're going to learn how to solve some exponential and logarithmic equations. So let's start with some equations that you can probably figure out how to solve. In fact, I'd like you to look at these two and see if you can solve them on your own, just based on what you already know. So go ahead and pause. Okay, so now let's see if you are on the right track. This first one, there's two ways you can approach this. One is to write both of those numbers, the 8 and the 4, using the same base. So write them in exponential form using the same base. So if you recognize that 8 and 4 are both powers of 2, this is a convenient way to solve a problem like this, because you can rewrite 8 as 2 to the third power, so that's 2 to the third to the x power, and 4 is 2 to the second power. So now we have the same base. This one, 2 to the third to the x, using our power exponent rule, we can rewrite it like that, because that's just 2 to the 3x. And now this becomes a very simple equation to solve, because this has to equal this in order for that equation to be true. So we simply solve the equation 3x equals 2, which is x equals 2/3. So that's one way you can solve this problem. Another way to solve it is, let's make some space here, is to rewrite that exponential equation as a log. So if we rewrote that, we'd have log base 8 of 4 equals x, and then you could simply put this expression into your calculator, and your calculator would give you 0.6 repeating, which is, of course, 2/3. You'd get the same answer. Either method is fine, but you should know how to do both. Okay, the next one, this example here, this one you're going to want to rewrite in exponential form. This one's a log, so that becomes 2 to the 4th equals x plus 1. And now you have actually a very simple equation to solve. That's just 16 equals x plus 1, so x is 15. Okay, now let's move on to some more interesting problems. Here we go. So same kind of concept here with this first one. Two ways to solve that. One way, using it, again, if you recognize that 5 and 125 are both powers of 5, you can rewrite this as 5 to the 3x minus 6 equals 5 to the third power. If you happen to recognize that 5 to the third is 125, and then you simply have to solve the equation 3x minus 6 equals 3. Because again, that exponent and that exponent need to be the same in order for that equation to be true. And you get a pretty simple equation. 3x is 9 and x equals 3. So that's one way you could go about solving this problem. And then the other way is to convert it to a log equation. And if we do that, we rewrite this as log base 5 of 125 equals that 3x minus 6. And log base 5 of 125, again, if you recognize that that's just 3, then you can evaluate that, or if you plug that into your calculator, you would end up with essentially the same equation you had the first way we solved it, and you still get x equals 3. Okay, and in this one you're able to get an exact solution. Okay, now in the second one, our base is e, so that's kind of a clue that we may not be able to get an exact solution, but we may need to use our calculator to solve. So first, I need to get rid of that coefficient there. I want to write this in exponential form, in other words, nothing out in front of that e. So I'm just going to divide both sides by 4, so that I have e to the 2x is 5/4. And now we can't use the first method that we used up here, because I can't write this as e to the something. Definitely can't do that. So I'm going to use writing it as a log equation. But of course the base here is e, so instead of a log equation, it's going to be a natural log equation. And we're going to have the natural log of 5/4 equals that exponent of 2x. And now I'm just going to get x by itself, dividing both sides by 2. And we're left with the natural log of 5/4 all over 2. And that, at this point, you would simply either leave it like that or approximate your answer by plugging that expression into your calculator. I would go ahead and do that, make sure you can type it in correctly, and you should get approximately 0.112 if you're rounding to the nearest thousandth. So that's how you solve those equations. That's all for now. Thanks.